Hi, I'm Zach Zink. We all go to Alec Tech for the Mechatronics program, and this is the Sandwich Artist 5000.
I'm Zach Zins.
I'm Dylan Kluber.
I'm John Miller.
So the reason that we had to do this project was it kind of encompasses all of our knowledge from the last 2 years and puts it on, a physical thing. So it takes everything from pneumatic to CAD to programming to electrical, everything that we learned in school.
Timeline of the project, we started out in the design phase, brainstormed a couple ideas. We originally were going to go with a conveyor, but change it to an air cylinder, figuring that would be easier. We didn't really know how to do the bread and that kind of stuff. Figured out all the issues that we thought we would encompass with it. Next we went on to actually putting it all together. All 80-20 frame, laid it all out. Then we started designing, went into electrical and pneumatic design, figuring out and sizing, air cylinders and what our CV values were going to be and stuff like that. And then went into what type of electrical sensors we were going to need, capacitive, conductive.
And then we went to putting the whole thing together and programming it. So in the project I did all the CAD, and then I helped with mechanical assembly and assisted in the programming of the project. So I got tasked with pretty much drawing the entire thing. We started from scratch and had to find all the parts that we needed for it offline in CAD form and assemble it all together. I have about close to 13 hours of CAD into it, so it was quite the task, and it took me quite a long time and some late nights. But we got it drawn up and we had to make a couple revisions on some few things, and it worked pretty well. Here's one of the pieces, or the main piece of the CAD that I drew fully assembled, and we have some revisions in there also.
So my contribution to this project was fabrication and assistant programming. I machined out all the brackets, cylinder mounts, bread plates, even the cylinder mounts to hold them to the plexiglass, machined the plexiglass. Our frame is made entirely out of 80-20 extrusion. Machine the mounts for the buttons. Help with the main program, and that's about it.
My name is John, and I was the pneumatics guy for our team. I also helped do some of the programming, and I had to size all the cylinders and correctly mount flow controls in line, and then come around the back here. I had to make sure the valving was correct to allow the certain amount of flow and pressure that we're going to use for our system.
I was in charge of the electrical schematics and all the electrical, designing of the project. We started out with laying down 5 sensors that control when the plate stops at each station. We originally had sensors on the cylinders, but we decided to take those off and just do it all pneumatically. Got 4 push buttons on the side, or on the controller. Got a start button, stop button, mustard and mayo selections, along with an auto man selector on the side. Controls when you want to go through the manual mode of the machine. If we walk around to the back, we have the PLC, the power supply that we sized. I had to design all of the electrical terminals, label all the inputs and outputs and stuff like that. We went with a 1500 Micrologics PLC, and then we actually ran out of inputs and outputs on it, so we had to put an extension right here. That gave us an extra 5 and 6 outputs. All of our sensor terminals are right down here. Power comes in through here. Runs off of a 120 volt AC power conductor into the 24 volt power converter, and then that powers the PLC along with all the sensors and the valves on the machine. These are the electrical schematics that we laid out for our machine. These are all the inputs for it. You can see that we have the 24 volt power supply and lays out into the start, stop, auto man, mustard and mayo selectors, all the sensors. And then these are all the outputs that go to each of the valves that control the pneumatics for the cylinders.